Yeah. Uh, so, welcome, Alex. I think we're now live. Uh,
Hello.
so, I think we might need the audience to maybe comment or mention that the live stream is going well. Uh, I'm so happy to have you, Alex.
Mhm.
I've been following your activity, your posts about Dremio, about Iceberg, and you're a co-author of Iceberg: The Definitive Guide, which is, I think, it's a really nice book. It's on my reading list. I didn't came through it yet, but I will. Okay, thanks, Ahmed. Thanks, Hisham. So yeah, I think this discussion maybe or this podcast maybe will span a couple of other sessions. If you don't mind to be my guest for upcoming sessions, but I think we will start the discussion on setting the basics, the core concepts of the hype happening now. And let me start with something like a kind of metaphor or comparison between what's happening on the AI world, the buzz happening from the LLM, the agentic techniques, multi agents, all the things happening on the LLM world that's really disrupting the way we work, the companies, the development teams, all the world being disrupted by the LLM. I think in a parallel world, in the data engineering aspect or the data analytics aspect, there is another hype is happening, but it's not being grabbed as the LLM, which is the iceberg and open table format war that's happening maybe 3 years or 4 years ago and started to be very a hot topic in the data landscape in the last year or year and a half. So, do you agree that, Alex, that this shift or this hype, it's reminding us back with the Hadoop shift? Can we correlate these together?
Oh yeah, I mean, bottom line is that there's this constant desire for companies to have access to more and more of their data. And that was one of the reasons why Hadoop became so popular. The idea that, hey, you know, I have structured and unstructured data, and Hadoop is going to let me be able to one store and be able to run analytics on that unstructured data, but also able to let me store structured data in a much cheaper way for like ad hoc uses versus putting them in like a data warehouse. Now, of course, the problem was is you didn't have as much structure and a lot of the same sort of guarantees that you would in a data warehouse in your data lake. So you ended up having data swamps where you had many copies of the same data with different schemas and all these different things. And you know, even if you had really good data sets, you couldn't really update them or change them in really good ways. So you had a lot of inconsistencies and aka the data swamp. And then basically it doesn't change that people wanted that grander access to their data, and now so more than ever because of the AIs and the LLMs. Because basically, what happens there is that if you want to create a quality LLM, you need to give it context, and that means you want to have access to as much of your data as possible to give it that context. So now that need to have access to all the data is greater than before. Like before, people liked the idea of having all of their data, but oftentimes they didn't use most of it. Now they do want to have access to all of it because they can use it for training, and then basically they might not even realize they needed something when they ask the LLM a question. So now all that data that before was maybe not needed now becomes needed. So being able to make use of grander amounts of data becomes, and having it interoperable with all your other data is now of much more importance. And this is where like the rise of AI really coincides with the rise of lakehouse, because the idea behind the fundamental value of lakehouse is the idea is to be able to have all your structured data in a way that all your different tools and all your different teams can access it for all your different use cases. Because what happened before, different teams would have their, like, different business units would have their data in different data warehouses using different engines, using different BI tools that would have like different business logic scattered all over the place. So the problem, you didn't have consistent definitions of data, you couldn't move data around different departments very easily. So it created not only this extra work that had to be done to ETL data between these different business units, but also a lag of time. Like you basically real-time data wasn't possible because you're spending so much time moving the data around. So now with a lakehouse, you have sort of a target and saying, hey, we can land this data in this format from the beginning. And now everyone can still use the tools they prefer. If one team wants to use Dremio, they can use Dremio. If another team wants to use Trino, they can use Trino. If another team wants to use Spark, they can use Spark. We don't have to have that
Yes.
fight over what's the best tool, but we can still have a copy of the data.
Yes. So I think actually I can tap on this. So years back, we were obsessed about collecting the data, but we were not able to know how to unlock or to unleash the power of this data. But I think now it's became more obvious on what tools, how we gonna integrate the data together and build something that can benefit from this tool. I think this is maybe tapping on what you've been saying is the technology or availing the technology that can unlock the collection of all this data instead of having a data swarm, so we can convert just the data to a more tangible metrics or decisions.
Agreed.
Right.
So yeah,
Yeah.
agreed. And
Yeah.
again, it enhances all your AI projects, but it also enhances all the existing types of workflows, whether they're just like other ML workflows or BI dashboard workflows. Everything gets enhanced when you can have sort of a canonical version of your data that is just interoperable with all your tools. So basically, every workflow becomes just
Yes.
easier with more consistent data.
Yes, and I think we didn't mention or didn't talk a lot about the your work at Dremio or head of DevRel, and I'm keeping this to the part of Dremio and the use cases. But yeah, I think you have lots of things to discuss, and also uh, getting the hidden gems from the iceberg, the definitive guide. So I think we're gonna discuss this through the podcast. But before jumping into the nitty gritty things about the lake house or the iceberg file format, can you give us a quick glimpse about the history or the evolution of the open table formats, something like Parquet or similar file formats that evolved and the need evolved from the market to have something like open table format like Howdy, Delta, Iceberg, and yeah, I think touching the base on the history or the evolution will make it easy to understand the complexities behind it.
Got it. Okay. Would it be okay for me like the whiteboard that story?
Definitely.
Okay, so I'm going to share my screen.
Yes. Go ahead.
Here we go. Cool. And then can everyone see the 2 QR codes on my screen? I'll take that
I
as a
can see
yes.
it.
Okay, perfect. Okay, so just before I start whiteboarding, these 2 QR codes will get you a free copy of the 2 of the books that I've written. So if you want free copies of this book, take a picture of those QR codes right now. I'll put them
Let me
back
do
up a little bit
it.
later on. Yeah, so I'll leave it up there
Yeah.
for like another 10 seconds, and then we will
Yeah.
go for it. Okay, cool. But bottom line is like, let's just think about like, hey, we move to data lake. Okay, so now you have your Hadoop data lake. So here's your Hadoop data lake. Okay, and we won't get into the mechanics of Hadoop with the cluster of nodes and then the master node and the name nodes and all that stuff. Hadoop cluster, but the main thing is basically think of this as your storage. Now, in the early days, we would just kind of store data in file formats that we were used to, things like CSV, JSON. Now here we start running into a problem. Okay, CSV and JSON aren't they're great for like configs for small data sets, things like that. But when it comes to running analytics, they can be real bottlenecks. One, because they're encoded as text. So because they're encoded as text, it takes longer to read them because you have to kind of first decode the text and then parse the file. With a CSV, there's no schema. Everything is kind of row based. So you have to kind of read every row before you can really do any analytics. Which becomes really cumbersome for large data sets. JSON, you have this semi-structured data that you have to kind of traverse. So overall, they're not the fastest ways to work with really, really large data sets. So the first thing that kind of helps make the data lake more useful is trying to come up with a better format than this. And this is where we start getting into like Parquet. So we're like, okay, well, if one of the problems, this is also like Parquet, ORC, but we're going to focus on Parquet. So if we think, hey, one problem is that their text encoded, how about we encode it as binary? So that way you just read binary data and you don't have to do that whole step of first, encoding encrypting the text or understanding the text and then parsing the text. You can just go straight to the data. So right there, you can pack the data in a much smaller amount of space and also read it much faster. But then two, the way you organize the data, one has a schema, two is columnar. So you're saving each column as a separate data structure. So that way you can only grab the columns you need instead of having to load every column for every row. And add metadata so that way you can determine whether you even need to read certain chunks of the file called row groups or not. So all these different aspects of the Parquet structure just allowed it to be a much faster file to read. And that's great. So now I can hold a data set in a Parquet file and run analytics on that data set much faster. And I could fit a much larger amount of data in the same amount of space. Wonderful. And everything is good long as I'm in one Parquet file. Now, what happens now when I have like the same data sets now stretched across multiple Parquet files. Okay, so let's say this right here, this is technically, let's say, my sales data set. Okay, let me send that backward. Okay, so this is my sales data set. Wonderful. So the problem is these files don't know that they're part of the sales data set. So in that case, when I run a query on it using a tool like a Dremio or a Trino or an AWS Athena, okay, it basically has to read. I have to tell it which files to read. So I have to say, hey, go check out these 3 files for the particular analytical task that I'm going to give you. Okay, and that could result in problems. What if someone else does the same sort of analytical job, but when they write their script, only specifies these 2 files? So now there's a whole chunk of the data set that they forgot to put in their definition, resulting in inconsistent analytics. So now you have a new problem. How can I consistently define the data sets? And also be able to run SQL, because if I want to run SQL, I need tables. So this is where Hive comes in. Okay. And basically Hive says, what we're going to do is make your life a lot easier. You can write SQL. We'll convert it into what's called MapReduce, which was the way you would write Java-based analytical workloads on your Hadoop cluster. And all you have to do is just say the name of the table. But again, it needs to understand what is the table in a consistent way. So the solution at the time was to say, hey, how about we put all of these files in the same folder? So we'll put it all in a folder called sales. And now all the Parquet files or all whatever files that are inside that folder are the sales table. Okay, and that's good. So now if I could write select star on sales, it's going to go to the sales table because Hive knows that folder is the sales table. Read all the files. It still has to read all the files, unless I partition them. But even then, there's all sorts of bottlenecks. But it's better. Okay, and I now at least have some consistency. But again, when it comes to like, hey, if I want to update a file, like, then if I update one of these Parquet files, the data set has changed.
The biggest problem, yeah.
Yeah. So then,
which is the norm of the data, that it always in a changing state. So yeah.
Correct. So people are editing files. So there's not really a good no good guarantees on knowing, hey, what version of the data I changed, because there's no tracking of the historical versions and all these things. So what we're doing with the modern table formats is we're moving away from saying, hey, let's take a look at the table as a folder of files, to taking a looking at as a list of files. So when we take a look at a modern table format, like an iceberg, basically what happens is that there may be a folder with the files, okay? But what's going to happen is that every time the table changes, we are creating a snapshot. Actually, let me change this to like modern table format. Okay, so we'll say, hey, this is a snapshot. So this is a version of the table. And this version of the table includes this Parquet file. Okay, and then basically, let's say now we add this Parquet file. Then we create a new snapshot. And now that snapshot says, okay, hey, this Parquet file and this Parquet file are part of the table. And the beauty of this is having this snapshot isolation, being able to actually go back and say, hey, this version of the table included these data files. I'm able to consistently say, hey, the data at this point in time looked like this, because I can always time travel back to a previous snapshot and find the right Parquet files that were part of the table at that time. So that's what we talk about with like snapshot isolation. But these snapshots or these table formats also include metadata on these Parquet files. Okay. And this metadata could include things like column ranges, partition ranges, number of nulls, etc. Okay, it has all sorts of information that I can use to understand these files that are in the table without actually having to read the files. So by being able to know, hey, what are the column ranges in a particular file, what can I do? Like, let's say we have a query that says select star on from sales where total, let me fix that, sales where total is less than 100. Okay, so now when we parse this query, a tool like Dremio could take a look at the metadata for each file and say, hey, for the total column, does the range include values under 100? Because if it doesn't, I can just skip reading that Parquet file or that partition in general. Okay, so now instead of me having to go read every file that's part of the table before running my executing my analytical process, I can actually just eliminate whole chunks of files or whole files from ever even having to be scanned or read, allowing much faster analytics. And then again, I have time travel because I have snapshot isolation, but also that snapshot isolation allows me to have guarantees. Because what's going to happen if somebody else is editing the table, like someone adds another Parquet file, okay, if that snapshot hasn't committed, it doesn't affect anyone reading the table because they're still going to be reading this snapshot. They don't care about the snapshot that hasn't yet been created. And they're still going to know that currently these are the two current files that should be read of the table. So that ongoing write doesn't affect them. It won't change what they're going to read. Okay, so you're going to get that.
So
Yep.
Alex,
Mhm.
if I would relate this, if I'm a novice computer science student, that I know how database work, how the NCs work, but I don't know anything about the uh, open table formats, the lakehouse. So
Mhm.
I can relate what you've been saying, like the metadata, the column range, the
Mhm.
partition range, as if it's the index in the
Mhm.
database that refer to the data ranges residing on the disk in the database. So it takes the same concepts and approach of building sparse index or SS tables, like something like this in the database. That's taking the same aspects and concepts in building the metadata that can refer to the Parquet files in the lakehouse architecture. Am I correct?
That's 100%. All basically these table formats are doing is just taking the way that a database is designed internally and making it a separate sort of out in the open file format based structure. So basically all those indexes that you would normally find within your database system are now just metadata files that any engine can read and leverage to traverse the files on your data lake.
I'm just mentioning this point because I'm always struggling with saying that it's always we need to go back and set back for the basics and concepts. So if we understand the concepts quite well, we can understand what's coming next.
Correct.
So
So none of the
please continue.
fundamentals have changed. At the end of the day, like whether you, and then this is essentially the high level of how Iceberg, Delta Lake, Hoodie work. Okay. And then, and essentially what happened is that there's another piece that's becoming a bigger and bigger part of the story nowadays, which again, is also part of any database, which is called a catalog. Okay. So essentially, this would be one table, but the thing is that you're going to have lots of tables in your lake. So in this case, what you have is a catalog that is aware of these tables, and technically Hive was a catalog, but I won't get too deep into that right now. But essentially, let's just kind of clean this up a little bit, and let's have multiple tables. So here's another table, call to orders. And the catalog is aware of these tables. Like basically, if we're talking about like Delta Lake or Hoodie tables, it's aware of which folder those tables exist in. If we're talking about Iceberg, it's aware of a particular metadata file. Okay, because Iceberg really relies on its metadata files to determine sort of what is the correct version of the table. So basically, every time you update an Iceberg table, you would update the catalog saying, "Oh, don't refer to this metadata file anymore. Refer to the new updated one." But either way, the catalog is tracking that. So in this case, an engine like Dremio or Athena or Trino, whatever query engine you want, that's the beauty of it. Any query engine can follow this pattern. You can now go to a catalog and say, hey, I want to query the sales table. The catalog will then tell it, hey, where the sales table is. And then Dremio will get the location of that and then go over there and begin reading pull those metadata files from storage to begin understanding the table and planning the query. Now, the cool thing about this is that what if someone else is running a query on the same table using Trino? Okay. Basically, these are two separate compute systems doing their own thing. So now Trino is going to go ask for that table catalog, then go to the right table. And now they're both going to retrieve those metadata files from storage, and they're both going to separately do query planning, and they're not sharing those compute resources. So you can have different teams with their own sort of compute resources running analytics on the same data without them having to like create bottlenecks for each other because they're not necessarily sharing the same compute resources. Okay, which basically allows allows this to be really scalable and allows the data to be really shareable, which is one of the nice things about this sort of structure. So I'll leave it at that for now.
Yeah. But if you can reshare again, please.
Oh, sure.
Yes, just put this on stage. So I think before moving to the next topic or question, so basically wrapping up that we started with CSV and JSON that were chaotic, unstructured, unable to process, to just Parquet file, which is columnar based storage that make aggregation and querying blazing fast, but yet we don't know where the files, what are the boundaries, the start and end of the files. Hence, it comes Hive and the metadata management and catalog management. So we isolated the storage from catalog management, from the processing power or processing engine, so that we have kind of layers or isolation between the engine, catalog, and data at the end, right? So
100%.
this is kind of wrapping up. Okay, perfect. But moving forward, we discussed in general. If you can touch base on why Iceberg specifically is making this buzz. We understand the concepts. What makes Iceberg different? What makes Iceberg super exciting for the big players to chase to acquire, other than Howdy or Delta Lake?
Okay, so I mean, part of it is just sort of like market dynamics. So basically, you have three main formats. You have Apache Hoodie, you have Apache Iceberg, and Delta Lake. And each of them had a sort of a different origin story. So, like Apache Hoodie started at Uber. Its main sort of design was really kind of trying to address the issue of like low latency streaming ingestion. So it's like really, really good for if you're trying to ingest data really fast, streaming wise. Because what it does, it divides the work up among a bunch of different files, and but it also is it's a little complicated because there's a lot of different files, but that allows a lot of concurrent work to happen to facilitate streaming. And then it has like this whole separate tool that kind of maintains the tables as they go. So one of the reasons why Hoodie doesn't have the same mind shares like Iceberg sometimes is partly because of its complexity. It's a little bit harder to understand. And it's really it was originally kind of really geared to a very specific use case. Then there's Delta Lake. Now, Delta Lake was built by Databricks. Databricks was trying to sit there and say, hey, we're going to do something different than a data warehouse. We're going to do this whole data lakehouse thing. So, but right now, just Parquet files or some limitations. We want to be able to treat data, have all these guarantees on the lake. So they built Delta Lake, but it was always kind of really built to work with the Databricks platform. So in that case, like all the features are not necessarily built directly into the Delta Lake format. It was always kind of very built with Spark in mind, and particularly Databricks Spark in mind. So like if you're using Databricks Spark, it can be a very fantastic experience to work with Delta Lake, but it's sort of very built with that in mind. And then the second part of the problem with like Delta Lake is because it is built specifically by Databricks, and Databricks has, while it is open source in the sense that the code is available, and many of the basically the way all these projects tend to work out is usually there's a Java library first. So the Java library comes first, and then people will build, a Python, a Rust, a Go version of it following the evolution of the Java library. So while there's a rich community that's building like Rust, Go, and Python, Delta Lake libraries, they're all following the Java library, which is generally very controlled by its roadmap, its direction, generally very much developed by Databricks. So when you think about that from an ecosystem perspective, if you're some other vendor building a tool, okay, if you were to build your tool and build first-class support for something like Delta Lake, you're essentially putting your company's livelihood in the hands of Databricks. Because what happens if Databricks completely changes the format overnight? Well, then basically your tool becomes useless, and then Databricks is going to be always at an advantage. So a lot of the industry didn't necessarily want that to become the standard because, basically there'll always be this asymmetry or this sort of unfair playing ground for the industry to build on. This is why you build on open standards like Parquet and things like that, because you want something that no one has one control over, and then two is built out in the open, so that way everyone knows what changes are coming ahead of time. Okay, so Iceberg, being an Apache project, is built out in the community. There's people from all sorts of different companies in there. Iceberg had a much more general use structure. Like it was built much more for not a specific use case, like low latency ingestion. It was built more for like, hey, general analytics. So it fit the bill a lot more for what most vendors really kind of wanted as an alternative to Delta Lake. So that helped build it like the momentum to become what it is now. Basically, it's something that any company who wants to build a product for the data community that they can build on, where basically no one has an advantage over anybody else. Like it's up to you to follow the spec. None of the features are hidden behind a particular vendor. Like all the features are really part of the specification. So you don't lose any features because you use, Dremio or Trino or whatnot. They're all part of the spec.
Yeah, we can say it's the general purpose open table format that's fits most of the use case without being targeted to a specific domain or use case. So yeah.
Yep. And one last piece is that because of that, all the different vendors have gotten behind it, and that then creates the reason why you would want to join it. Because wouldn't you want to use a tool that has like the support of the most tools in the ecosystem, so that way you have the flexibility to switch between different tools, and that ecosystem can be a really big driver. And that's, I think, what really clinched the deal for Iceberg.
Okay. I think one of the most interesting use cases that you mentioned it during what your last answer is really Iceberg just for specific use cases, something like not specific use case, but mainly under the umbrella of batch processing, or it could be integrated in the stream processing or streaming world.
Yes. Okay. So streaming is particularly tricky when it comes to data lakes and data lakehouses. Why? Because when you're having like this snapshot isolation thing, so let me just copy this piece right here for a second. Okay, so when you're having like streaming coming in, you're continuously ingesting data, and that means anytime you add data, you create a new snapshot. So then what happens? You're creating like snapshots very, very quickly. Okay.
Yes.
Which can quickly lead to like a lot of metadata files, a lot of data files that are really small. Okay, so this becomes like sort of a challenge. So streaming into the data lakehouse was always really difficult. This, like Hoodie kind of did this through like through a timeline type structure and having sort of like this continuous process. Now, the way it's kind of installed in Iceberg is oftentimes through like micro batching. So what you might do is that as records come in, so let's say here like records that are, or records that are or messages that are coming in through your Kafka topic,
Events.
Yeah, let's do that, events. So you might have the events, but what it might do is that oftentimes with like a lot of Iceberg systems, what they'll do is you'll set like a time frame saying, okay, hey, you know what, let's wait 5 seconds. Don't commit it right away. Let's just kind of wait like 5 seconds, see how many events come in within those 5 seconds. Okay, so they're coming in. It may write the Parquet files as they come in. So it's writing Parquet files, the data as it comes in. But then the actual snapshot gets created at the end of like the interval. Okay, so something like, let's say, the Kafka Connect connector for Iceberg, that's kind of how it'll work. There'll be like a window. It's writing the Parquet files as the data comes in, but then it'll actually do the final commit, the creation of that snapshot within the metadata within the interval. So that way, all those Parquet files that were written within that period of time are all committed within one snapshot. So you're not creating too many metadata files all the time, or you're not creating a whole series of metadata files for every individual thing you process. So that's kind of generally how it's going to be kind of handled with these kind of table formats. You kind of create like a little mini window. You're writing the Parquet files as it comes in, and then again you can then write the metadata at the end of the sort of that micro period of 5 seconds, 1 second, a minute, whatever you want. Okay. And again, this is the reason. I'll go for it.
No. If you have anything regarding this, let's mention it. But I think we might move to the next part, which I think would be the bread and butter for the talk, building on what you've been saying. So, okay, let's move to. We have almost 30 minutes. We'll have the session. Let's move to a real world examples and real world scenarios. Whereby companies now stuck with, or not stuck, maybe working with data warehouses, and they're fine with it. But engineering teams or data engineering teams are always under the pressure that we need to use the cutting edge technology or follow the buzz or the hype happening. When do you see that I have a data warehouse and I need to move to lakehouse or think of the lakehouse architecture? What are the triggers and criteria that I should say I see that this is the use case, or this is the data channels, or this is the data problems that I'm facing, and data warehouse will not be sufficient, and I need to move to a lakehouse architecture?
Got it. Okay, there's a couple of triggers. Like nowadays, what I would say, like if you're basically the standard evolution would be happens that someone usually would start with like SQL Server or Postgres as their database for their operations, and they would run analytics straight out of that. Like that's where they would start. Then over time they realize, okay, hey, running all these analytical queries with my operational queries are putting too much stress on the system. So then what they do is they might create like a replicate and have like 2 copies of the same Postgres database, one for analytics, one for operations. But then again, then you're going to hit scaling issues there. As the data gets bigger, that's not going to really work. So then usually after that, that's when you start thinking about like a data warehouse. But then what happens with the data warehouse is that one, the storage, the cost becomes an issue because they aren't cheap. They'll kind of run those systems and to scale those systems. Okay, so oftentimes that's going to be one of the triggers that's going to start getting people thinking, hey, what else can I do? At the end of this, what I'm going to say is that if you're that company who's getting at that point where Postgres and SQL Server aren't going to scale any further for you, honestly, I would just go straight to a lakehouse nowadays. But for those who kind of already gone to a warehouse, what happens is they're going to hit the cost barrier. 2, they might hit like the sharing barrier in the sense that you might have one department that's using Snowflake, another department is using Redshift, another department is using Synapse, and now you want to share the data, and now you're creating all these ETL barriers. So all this ETL that has to happen between these departments because each data warehouse stores the data differently, and it's kind of like in there. It's like a walled garden for that data. So there's like that sharing barrier. So usually you're gonna hit one of these two. Basically, either because of the way your company's set up, everyone's using different tools, and it's creating kind of these like barriers, or it's a cost barrier. What if you do have like the same data warehouse for your entire company? Well, what happens? You end up creating so many different marts and so many different copies of the data within that data warehouse. You start really feeling the costs. And basically, a lot of times people think it's like, okay, well, we only have like 3 terabytes of data. Okay, it's only going to cost this much. and then they get the bill and it costs a lot more because they're not factoring in things like the egress costs. If they're egressing the data from like a data lake, they're not factoring in that usually these data warehouses will like retain like the last 90 days of snapshots. So they're doing snapshot
Mm.
isolation under the hood, and they're retaining all those copies of your data, and you're paying for the storage of those copies of those historical versions. So you get time travel, but it inflates, and you're paying that higher storage bill on the data warehouse, and that's inflating it. So that's generally where you're gonna start seeing these pressures, where it's
Yeah. Yeah. So maybe mainly costs and sharing barrier. But
mhm,
let me take the other argument,
mhm.
whereby if I'm a small to medium company that uh, I don't have too much teams, don't have too much data to share between teams and each others, so data warehouse still could be a viable option, right?
Oh, I mean, oftentimes no, it totally is. Now the problem is eventually you're going to hit these barriers as you grow, and then you're going to move to a data lake house anyways. Well, a data
Hmm.
lake house can already save you money medium to small, because
Okay.
it's going to be much cheaper to store your data as Apache Iceberg tables on your data lakehouse storage. And nowadays, especially if you're in that medium to small size, you can probably run most of your workloads off a decent laptop. So in that case, instead of having to pay for like this persistently running data warehouse system and having to pay for like large Spark clusters to do all this ETL, you could probably just use something like a Polars or a Pi Arrow, and just have like lambdas. Like actually, no, actually fairly large companies are just doing this, where they
Hmm.
basically are doing almost all their ETL work into Iceberg off lambdas. So basically, it's all very ephemeral Python scripts that are doing incremental work. And instead of they wouldn't even like make it concurrent. So they wouldn't, like, let's say you have like five gigs of data, instead of having like five lambdas triggered to process 1 gig of data at the same time, basically at the speed that they can process 1 gig of data, they're like, okay, how about this? We'll just trigger that same lambda 5 times and just incrementally do that one, because it's the technology's there. It's like fast enough with that low at that level to do that nowadays. So in that case, you could,
Yeah.
and then people can access it. And then nowadays with the catalogs, like if you have an Iceberg catalog, someone can just put those Iceberg catalog configurations to a tool that's running on their laptop and be able to run queries on there directly from their laptop. So there's a lot of use cases where you don't need to have that persistent running compute, and you can save yourself a lot of money through serverless compute at that early stage. And now there's a company called Bauplan that's built a whole platform around like serverless Iceberg Python, where you can just do all this like serverless computing to your Iceberg Lakehouse through their Python runtime. So there's a lot of growing options, and something even like Dremio can be run on your laptop through a Docker container. You can connect it to your Iceberg catalog, and then just be able to run queries straight from your laptop without having to pay for any compute.
Yes. But this means that, taking from your answer, this
Mhm.
means that having both worlds, data warehouse and data lake house, uh, shouldn't live together, or they can live together.
They can. I mean, I would like basically what I say. It depends where you are in the life cycle. If you're a company who has not yet taken on a data warehouse,
Yes.
my recommendation generally would just be go straight to a data lake house. At this point,
Mm.
most data warehouses are becoming data lake houses. They all have this concept of like external tables, where you can have Iceberg tables and query Iceberg tables, but oftentimes it's like a secondary thought. So oftentimes it's like you have the ability to do that in the data warehouse system, but it's not oftentimes the best experience versus going to something that's more like natively built for the data lake house. And then, but if you already have a data warehouse, then in that case you can incrementally use data lakehouse and start offloading some of your data sets into Iceberg tables to reduce your costs, and still take advantage of the features that you like, or the sort of the things that are kind of hard to migrate off of within your existing data warehouse setup. So it allows you to kind of make that data warehouse setup that you currently have manageable within your costs, and make some of those data sets more shareable, without necessarily having to do a full-on migration up front, because most data warehouses will support this pattern to an extent. Again, usually it's the experience is definitely more designed for you to use their internal storage, but they now they understand the trend, so they've built features that allow you to kind of better use these other patterns.
Yeah, but building on this specific point, as
Mhm.
whereby we have tons and tons of companies that have already implemented data
Mhm.
warehouse, what are the tips and tricks of the migration? From where they should start? What are the steps, the low-hanging fruits? How can they
Mhm.
make this migration smooth?
Okay, got it. This is where and then this is just because I've seen this story several times, so I'm going to use Dremio for this example just because I've seen how this works out.
For
But
sure.
oftentimes what's going to happen is you see people have like a data warehouse. So let's say they have a Snowflake. They may still have some databases, around there with some other data sets that they haven't moved to the data warehouse. They may have some data lake data sets. Like oftentimes, like they might buy some stuff from like the AWS marketplace, and they might have some stuff in their data
Mm.
warehouse from like the Snowflake marketplace. So they have all these data sets. Now the cool thing is, what you can do is you can use a tool like Dremio, as sort of like this unification layer. So basically, the first step in the migration. So let's say the end goal is to move most of your data sets over here to your Iceberg lakehouse. So let's say here you're using you're using Polaris as your catalog with S3 as your storage. Okay. First step, right now there's no tables in your Iceberg lakehouse. I would first
So
connect.
I'm sorry, Alex. I will relate. I'm the let me be act as the student. So
Mhm.
the Polaris here we can match it with Hive, like
Yeah,
the catalog management, and the S3 is instead of Hadoop file structure, so we use S3.
100%. Yeah, this is just an
Perfect.
example. Yeah,
So
and it could
yeah,
be Hadoop. So it could be Hadoop and Hive. Polaris,
yes,
it could be a bunch of different things. But the idea is that
yes,
it's a catalog and storage. Um,
clear.
and then all that can connect to Dremio. So now from Dremio, I can now what I'll do is that maybe I have this tape. I'm going to start creating what's called a semantic layer in Dremio because Dremio has a built-in semantic layer, which you
Okay.
curate using SQL views. So what I might do is I'm going to end up creating 3 layers of views. So we'll have we have different, you see people call them different ways, but I'll keep it simple and say bronze, silver, gold.
The
Uh,
medallion architecture.
yep. So, but in this case, it's all SQL views. So in this case, my bronze layer is really just going to be select star views. So in this case, I might have a view here, and really all this view is saying it's like select star from, customers. Well, let's say like Snowflake dot customers. Okay, because I connected Snowflake to Dremio, and now I can query the tables from Snowflake in from Dremio. So now I've created this view, and then maybe I'll have another one that's like Postgres dot orders. So I mean, basically the first step here is just to kind of build this workflow on your existing systems. And you'll see how this is going to make the Iceberg switch much, much easier in just a moment. Done backwards. Okay, so theoretically what would happen here is once I create all these views, I would then like create, keep doing my modeling. So then maybe over here we have my join. So here I have another view that's a join between these tables. And then in my gold layer, I may have like a couple different views. So this might be like March sales.
The aggregation layer or the
Yeah,
golden layer. Yeah.
April sales. You get the idea. So basically, I have the semantic layer all built out in Dremio. But what matters is that these raw views are pointing to the old sources. So eventually, what I might do is I might choose one table first. I'm going to choose my customers table. I'm going to migrate my customers table. And going forward, I want to land that as Iceberg instead of landing it directly into Snowflake. So behind the scenes, I do that. Once I actually have that table ready to go, and it's in my Iceberg Lakehouse, then all I have to do without having to interrupt anybody's workflows, because everyone's workflows are working off all these gold views, all I do is I go back to my bronze layer, and I'm just going to update this to say, point to the version of that table going on the Iceberg source. And now technically all of my workflows have just migrated over to that Iceberg table without anyone having to change anything that they're doing. Everyone just keeps working the way they've been working. It basically becomes a frictionless change, because what you did is first you build that semantic layer and everyone works off the semantic layer, and you can then just swap which version of the same data set at that raw layer And then all the views you built on top of it just kind of work right off of that.
Perfect. So this means that I can incrementally change the semantic layer step by step without taking all or none. I can switch or uh, replace table by table so that I can test and evolve as I go without making a massive change to change everything at the same time. So incrementally, I can build, change, test, and validate the quality step by step.
Yes, and that's what makes Dremio such a powerful tool for this specific use case. Just because generally with like a lot of other platforms, it's kind of like you have to kind of basically move all the way over the iceberg overnight. So then basically it's a much harder migration. It's a much longer migration, less testing. So here you can really do it incrementally, but you don't have to wait to get the benefits because Dremio has a feature called reflections. It's like materialized views. But what I can do is I can sit there and say, hey, I'm going to create a reflection. Well, I'll just say this is a reflection, create a reflection on April sales. And technically what's going to happen is that Dremio will make essentially a mirror, a reflection of that data set, an iceberg on your data lake. And then from the point of view of the end user, they don't need to know. They're just going to keep querying the April sales, but Dremio will substitute it. Will substitute the iceberg version when it comes in. And I don't have to do it here. I could maybe do the reflection over here. So that way, when this was Snowflake, basically Dremio will already be creating sort of like a mirror, a iceberg-based mirror off on your data lake to the side. And then when people query the Snowflake data source, Dremio will just substitute it, saving you money on your Snowflake compute because you're not technically sending that query to Snowflake anymore. So you're already starting to get some of the cost savings and performance benefits up front while you do your migration. Like you still eventually want to do the migration because what happens is that once you are actually natively in Iceberg, Dremio can then update these reflections incrementally, and they get the updates get triggered when the actual Iceberg table changes. So these become a lot more powerful at that point.
Okay.
But yeah.
So since we started to talk about the actual architecture and use Dremio as maybe a step to migrate my old data warehouse, data lake, or database, mirror database to the lakehouse architecture, if you can touch the base on how Dremio work under the hood, maybe in a nutshell, since we have only 12 minutes for this session, and I have a couple of few questions to ask. So if you can give us a glimpse about how uh, engine like Dreamy work under the hood, does it pull all the data? If I'm processing lots and lots of amount of data, let's say the bronze layer. So when I run the query, does it get all the data and process it, load it from the disk and load it in the query engine to do the processing, or does it process it in incremental approach, or how the query engine for Dreamy works under the hood?
It's going to be a mix of two things. So part of it for like a data source, like a data warehouse, like a database, what it's going to do is it's going to initially try to push it down as much as it can. So what it'll do is it'll try to come up with a Snowflake query where it's going to offload as much of that work to Snowflake, so that way it's only getting the data that Dremio absolutely needs to move forward. So basically, a query will get sent to Snowflake absent of reflection. If you have a reflection, then it'll just use the reflection, which acts as a cache. But it'll initially push down here and here. Okay, and then what's going to do is going to take that data that it receives from Snowflake or Postgres and then load it into Arrow. So it uses Apache Arrow as its way of representing the data in memory. So now for the data lake sources, what it'll do, it will read the data. So it will then fetch the data, fetch and read the data directly into Arrow. So there's no push down here. It's going to go fetch the data, load it up into Arrow, and then process it from there. Same thing with like Iceberg. Although with Iceberg, you have that metadata, so that way, instead of reading every file, it can eliminate a lot of the files to read. So it only will read the files that it absolutely needs. But essentially, let's say we're doing this join here. It'll first push down a query to Snowflake and push down a query to Postgres, get the data it needs, load it up into Arrow, and then execute the join. And then Dremio will execute the join among those Arrow buffers. And then Arrow allows for really, really fast processing. So it actually does it really, really performantly. Now, in the situation where I do have a reflection, so in this case, let's say I have this reflection on Snowflake, on the Snowflake data set, in that case, it would skip pushing down from Snowflake. So that's how you save yourself the Snowflake compute. And it'll instead go to your data lake and grab that Iceberg version that Dremio created on the side. And then it'll load that as Arrow. And then again, it'll still push down to Postgres. But depending on the data source, basically it'll either fetch the data from your data lake or push down the query to the database or data warehouse system to initially fetch the data, load that into Arrow, and once all the data is in Arrow, it then executes. Like there's several different caching layers throughout, but that's the general like gist of like the workflow for Dremio.
Okay, so this means that if I have terabytes of data and I want to do kind of processing on this terabytes of data, and let's assume that we're on Iceberg instead of data warehouse or database or whatsoever. Just we're on Iceberg lakehouse. So this will end up loading all the data. So it's kind of memory and CPU intensive process that will it kind of load all the data or
no. Not necessarily. So it depends. Like if it's Iceberg, it's not going to load all the data into memory because it can use Iceberg metadata to eliminate different files from the query plan. If you're talking about like, let's say Snowflake, what you would do is typically, instead of creating like a reflection here, I might create the reflection here on the join. So that way, maybe this join only gets and I'll set this reflection to refresh like maybe once a day. So then it's only going to do this join once a day. So it only runs that query once a day on the larger data sets. And then I might then this join will then be used to then be to curate all of these. So basically, you're taking a bit of that. A lot of the processing has already been done and cached as that reflection.
Yes.
But again, it also depends on sort of what you do as your initial query. So in this case, I may not want to start. And there's also some things you can do in Dremio where you can actually specify subqueries for fetching the data. So like you can actually like Dremio will figure out its own pushdowns, but you can actually sit there and say, okay, hey, here's the query I want you to start with. Send this to Snowflake, and then work with the data from there. So there's different ways to optimize it, but Dremio will generally intelligently figure out, hey, you don't really need all the data based on the query you gave me. You really need this data, so I can send this query to Snowflake, so I only get the subset that I need.
Yes, and actually, this is specifically this answer. That's what I would love to hear, so that I want to make sure that for the audience, it's not a silver bullet, or it's not an easy way to do your analytics. It requires to understand how things are working, how what fits the best for your use case and your situation, and the nature of the data source make big difference. The rate of change of the data makes a big difference. And as you mentioned, you move the reflection from the bronze layer to the silver layer. This might enhance a lot the query performance, the cost of the query, lots of things. So I think it's really important not just follow the buzz. You need to understand the details or how things working under the hood to make a good use of the technology. It will not work on its own. You need to understand.
Yeah, it's not. Yeah, I mean, it does make things easier, but at the end of the day, like nothing's going to. Well, I'll caveat that, but you still need to understand your data. At the end of the day, like you definitely need like all those things you just mentioned. You need to know like how fast your data is coming in, how often those data sets are changing, which data sets, which data sets are the high value ones. What are the SLAs that people need? Like, hey, if people are okay with data sets that are fresh within a day, then that's going to change your decision versus if they need it to be real time. But one thing to keep in mind is that this is Dremio when you're using mixed data, but when you move to completely an Iceberg, so let's say you complete that Iceberg migration, Dremio does sort of like have an upgrade in a sense that one, reflections are going to be updated when the data sets update, and they updated incrementally, so they're a lot cheaper. And then two, there's going to be autonomous reflections, so you don't even have to figure out what the right reflections are. Dremio will monitor your activity, and it will create and decommission reflections for you based on your query activity. But that only works on the Iceberg tables. So it's one of the reasons why you'd want to migrate to Iceberg, so that we can get all that autonomous data management that Dremio can provide.
Okay, last question about Dremio, and we can move to the next question.
Yep.
Does Dremio offer out of the box any other data governance, data lineage solutions for as an end-to-end data lakehouse?
Yeah, I would think of it as like a lakehouse in a box. So when you build a lakehouse, you really need three things. You need an engine, so you can run queries on your Iceberg tables or whatever data lake house table format. You need a catalog to track and govern those tables. Okay, so Dremio has a built-in catalog, so you can use other Iceberg catalogs, but the Dremio platform does have one built in that you can use, and that you can then also govern your tables from. That does support the universal Iceberg REST catalog interface. And then last, you need table maintenance. And this is the thing that a lot of people don't realize until they're too far down the rabbit hole, that it's not a database. At the end of the day, with the database, under the hood, that database system is running 24/7, and it's doing all sorts of optimization of how this data is physically stored when nothing's happening. So basically, things are just kind of always working. But with Iceberg tables or with data lakehouses, you don't have this sort of perpetually running compute that's kind of figuring that out. Dremio provides that. So basically, when you're using the Dremio system, the tables that you have in your Dremio catalog will automatically be maintained by Dremio. So then all that sort of optimization, maintenance, and cleanup will be done automatically for you. So it makes the whole process of executing a lakehouse much easier, because it provides you the engine, which has a semantic layer, has lineage, provides you the catalog so you can track your tables, bring them to any engine you want, and have the same governance rules applied. And it gives you the table maintenance, so that way those tables are always performant because they're being optimized. And with a very unique feature of Iceberg clustering, which right now we're the only company that's offering Iceberg clustering, dynamic clustering
Okay,
for Iceberg.
I think we have 3 minutes. I'm not sure, Alex, if you can expand on maybe 3 or 4 more minutes. We have a
Yeah.
couple of questions regarding this. Let me show. Someone's asking premise solutions.
Okay. Can you repeat the question, because you cut out just for like a moment?
Yeah, can you see it on the screen? It's does
Oh,
Dremio.
let me just change the windows.
Ah,
How does Dremio offer? Yes, actually, Dremio is really popular on premise. So Dremio can be deployed on prem, because Dremio can be deployed either as a SaaS, or it can be deployed as software. So basically, we can deploy it in a KS environment anywhere. So we're really popular for on-prem, because basically, when it comes to, especially with like Hadoop, we work with Hadoop, we work with pretty much any object storage you can think of. So a really popular pattern is like that whole migration story I told earlier. A lot of times people want to move from like Hadoop to like something like a MinIO, so that way they can have that more modern object storage, and they'll use this pattern. So in this case, let's say this is Hadoop, and then this is MinIO. They'll kind of connect both to Dremio, build that whole semantic layer on top of their existing Hadoop lakehouse or Hadoop lake, and then little by little incrementally move that data over to MinIO, and then again just update those raw layers. So basically, Dremio works in any environment. It could work across clouds, on premise, anywhere you can have a Kubernetes pod running, or a Kubernetes cluster running. You can just plop Dremio there, and you get that full end-to-end lakehouse platform. You can connect whatever your existing systems are and do this kind of migration pattern, regardless of what the destination system is. You just set up that semantic layer on your existing systems, and then incrementally move data sets to sort of the new destination, and update your semantic layer as you go.
yeah, and Dremio is an open source and community powered solution. There are lots of things that are offered in the SaaS, but it's I think also it's an open source, so you can benefit from the open source package from Dremio. You can try it yourself for free to get the sense how Dremio work, how it's under the hood is working. So yeah.
Yeah.
So moving to the next project, since we're discussing and we started the very first statement about AI, I think we need also to make the outro with the AI. How do you think the AI or Iceberg, sorry, is empowering the LLM, or could empower the LLM, the agentic AI world? Do you
I think that
see any
yeah. Bottom line, like, it just makes more of your data more accessible across. So imagine a company that then standardizes an iceberg. So now all their data across all their different departments are now in sort of one standard business unit that everyone can work with. But that means it's going to be that much more accessible to the AI tools as well. And people are creating like Iceberg MCP servers that allow basically they're designed to communicate with an Iceberg catalog. So that way you can basically allow you to use LLMs against your Iceberg catalog. But also when it
Mhm.
comes to like training data, it's just going to make the data more accessible. Um, basically, for example, in Delta Lake, for the longest time there wasn't a catalog until Unity catalog recently. So the way you would share data is you would use what's called delta sharing. So it was just an API where you can kind of say, hey, you can request the data files so that way you can bring your own compute. You don't need that in Iceberg because the catalog kind of serves that role. In this case, you can connect whatever your compute tool is to the catalog. And the reason I say that, it just becomes much easier to share data. So not only
Mhm.
does it make it easier for you to have your company's data, but other people who want to share data with you, it's going to become a lot easier because they can just provide you credentials to their Iceberg catalog, and then you can access the data sets that they want to share with you very easily using your own compute. So it'll over time, I imagine there'll be marketplaces that are built around this sort of catalog level sharing. But that'll also, again, just basically make data sets where you don't have to necessarily go wrestle with like AWS and then wrestle with Snowflake. They'll just be sort of the Iceberg catalogs become the marketplace.
Yes, yes, I totally agree, Alex, about this, and I
Mhm.
see that the evolution of AI, it will definitely empower the or be empowered by the lots of hypes happening in the data analytics and data engineering world, whether from streaming platforms like Kafka, Flink, uh, and moving to the Iceberg and Lakehouse to make the best benefit. Last question, and I'm really looking forward to expand the discussion for another session. But last and but not least, the last question about, I think, the million-dollar question that everyone asks: do AI will impact the software industry? For sure, I think lots of people are thinking no, it will not, but others thinking that it will. But we're not talking about software engineers right now, maybe about the data engineers. Do you see, or do you think that AI and Gen AI and LLMs will harm or impact the demand or the need for the data engineers?
No,
Or
I don't think it's. I mean, basically what it does, it changes the demand because the things that were the low hanging fruit, like more like the typical entry level task before, are now much easier because of LLMs. So this changes what's expected at the entry level. So I would say it's not this. There's still demand for data engineers because at the end of the day, like LLMs can't do everything, and then basically as LLMs do more, what's needed changes. So there's always going to be like this chase. But the thing what happens is that what you need to know to start becomes different. Like you'll still need to know all the fundamentals. Like same thing with like software engineering. Like you can use LLMs to write code, but you still need to know how you would have written that code because you need to be able to make those architectural prompts in an effective way. So basically, it just creates it makes where you need to be at the entry level just a little bit deeper. Like the work again, doing those individual tasks become easier, but you still have to understand those tasks, even though they are easier. And that's where it becomes harder, a little bit harder, because you'll have to have a deeper understanding to get to, let's say, level one. While if you're already on like level 2, 3, 4, you're good. All it's doing is enhancing your productivity. Um, like if I were to imagine it, like you're walking up a ladder and the water is rising.
mm,
Okay. So if you're already farther down the ladder, like it's not affecting you at all. The water can keep rising, you don't notice it. But if you're depending where you are, you'll start noticing it because it's the demands on you are more.
can't agree anymore. Can't agree anymore. I have a post about this maybe a week ago,
Mhm.
and there were lots of challenges about this. But yeah, I 100% agree. One last advice before
Mhm.
we close the podcast for today. One last advice for data engineers.
I mean, honestly, when it comes to any technical work, the basically the number one advice I can give is stay hungry for information. Like at the end of the day, like long as you're learning, and again, it doesn't mean you have to always learn every little new hot thing. Like like let's say like Duck Lake yesterday. Like just because Duck Lake had a big hype day yesterday doesn't mean like your yeah like doesn't mean like your career will hinge on you learning Duck Lake in the next week. But one, be aware of what people are talking about. Um, follow a lot of other people in your space so you can see what are the common threads of what people are talking about, and that'll help you guide you and maybe what are the things you want to follow deeper versus others. Because some things will just show up for a day and everyone will be talking about it for a day, but what are the things you hear people talking about every week?
Yeah,
Those are going to be the things you're going to make sure that you're not, you don't have to be an expert in everything, but you want to make sure that you're well acquainted enough to think through that higher level. And at the end of the day, it's always I always find it, the actual technical how to do everything step by step is great, but more importantly is always trying to work on developing that architectural high level view, because that's what becomes the more valuable skill in the long run. As LLMs become better and better at doing the step by steps, it's the architectural end to end vision that becomes a thing that it can't do, that we can bring to that we'll always be able to bring to the table, just because until like the context windows become like ridiculously large. I mean, I guess I mean, there's some ways, but like at the end of the day, like
hope they didn't reach this state.
yeah, but I mean, at the end of the day, like it's the imagination, being able to imagine
Yes, yes,
using
yes.
knowing what is and imagining how you can put those things together into something that hasn't been, is going to be the most valuable skill you can have that will never be um, replaceable. I don't think, at least not in the
Mm.
next. But I mean,
At
it keeps
least we're
surprising
still,
me.
at
So
least
who
we're
knows?
still in the service and still working.
Yeah,
I can't thank you anymore, Alex. It's really pleasure to have you my guest for today, and I think we need to expand this for Duck Lake. That my
yeah,
bad that I forgot to mention, but we're running out of time.
it's all good.
And
We have
the demo for Dremio, building a basic lake house using Dremio. So maybe
yep.
we can schedule for another one
Mhm.
once you're okay. So thanks a lot, Alex.
Thank you,
Thanks a lot for the audience for staying with us late. And yeah, looking forward for the next episode. Thanks, Alex.
thank you.
Bye bye.